All right, for question 27 and 28, I'm going to go ahead and skip those since we really didn't cover proofs or this mapping of these complicated polygons. So we're going to skip those. Don't worry about it too much. If you see questions like this, for the mapping, what I suggest you do is just take 5 and divide it into 12 and see if you can try to match up numbers that way. And what you're trying to do is you're trying to figure out a scale factor. So a number times 5 should give you 12, and that same number times every other number should generate these other numbers. So for instance, 9 to 18 times 2, yes. 4 times 2 is not going to be 12, but so you have to find that common number. But in this case, I don't think it's going to work out. So that's why I'm mostly trying to skip it. So we'll continue on to the next questions. Okay, question 29. In this figure, if segment AB is parallel to DC, name the alternate interior angles. So this side is parallel to this side. I'll mark my shapes here. Alternate interior. So that would be this angle with this angle. So we could say angle B and angle D, and angle C here with angle A. So those will be my alternate interior angles that are marked very easily in that problem. Question 30. In the figure below, triangle ABC and is congruent to triangle MPN. Find MN. So since we're talking about MN, it should be compared to AC. So I look at AC. AC is 5, so therefore MN equals 5. Okay, complete the statement with one of these. So these are our choices, or no conclusion. So angle 4 and angle 12. If these two lines are parallel, this really is not enough information. These are on two transversals, and going the other way too. So in this case, I'm going to say no conclusion. Not enough information. Question 32. All right, for this question, same process. One of these lines or sets of lines are parallel or no conclusion. So we're talking about angle 6 and angle 8. Since angle 6 is congruent to angle 8, that must mean that these two sides are parallel because of alternate interior angles. So WT and RS are parallel. 33. Which lines, if any, can be proven parallel given the following diagram? For each conclusion, provide the justification. Well, 151 plus 29 is 180 degrees. That must mean that this angle and this angle are supplementary. And the rule that says if these two angles are supplementary is the same side interior angles or consecutive interior angles. So that would be our justification for two lines being parallel. In this case, line B parallel to line C. Question 34. Which lines, if any, must be parallel based on the given diagram and information? Give the justification for each conclusion, given angle 4 congruent to angle 12. So this angle is congruent to this angle. So if these two angles are congruent, these would be corresponding angles. And the rule says if corresponding angles are congruent, therefore our two lines are also congruent. So line C is parallel to line D. Question 35. So we're going to use this figure, and using this given information, angle 1 is congruent to angle 3. So this angle and this angle are congruent to each other. So that means that these are corresponding angles again. So line P and N must be the parallel lines. Okay, question 38. Which equation describes parallel lines? Parallel lines have to have the same slope. So that's what we're looking for. So slope is 0, slope is 1, slope is 2, slope is 2. So 3 and 4 are parallel. (37) Which equations describe parallel lines? Okay, again, same thing. It's that same slope. This one's 4. This one's negative 1/4. These two we don't know, so we're going to have to figure these out. So, let's calculate them real fast. This one wants to subtract 12x from both sides. And I'm going to just kind of put it over here. So negative 3y is equal to negative 12x plus 6 divided by negative 3. So in this case, negative 12 divided by negative 3, this is going to be a positive 4. So far, 1 and 3 are parallel. Okay, let's check out 4 here. We're going to distribute the 4. So that's 4y plus 24 equal to x minus 3. And subtract 24. So we're going to get 4y equal to x minus 27 divided by 4. Well, that's going to be 1/4, so that's not going to work. So our two parallel lines in this case will be 2 and 3. Okay, question 38. Determine whether the line through 0, 4 and 2, 0, the line negative 2, 3, and negative 4, 2 are parallel, perpendicular, or neither. So let's calculate these. We're going to use the slope formula, so 4 minus 0 divided by 0 minus 2, which is 4 over negative 2, which is negative 2. Over here we're going to do 3 minus 2 over negative 2 minus negative 4. 3 minus 2 is 1. Negative 2 minus 4 is plus, so actually 2, 1/2. So 1/2, negative 2, therefore these are negative reciprocals of each other, so my lines are perpendicular. Alright, use the figures to prove that angle 1 and angle 7 are congruent. Well, if these two angles are congruent, that means these two lines have to be parallel. If they're parallel, they have to have the same slope. So let's do this. Let's find the slope for m. So our rise, in this case, is going to be down 2 over 1, 2, 3, 4, 5, 6 for our run, which reduces down to negative 1/3. Same thing for this one, so it'll go down 2. And our run is 1, 2, 3, 4, 5, 6 again, which is negative 1/3. Same slope, therefore parallel lines, therefore angle 1 is congruent to angle 7.